Hello and welcome. You're watching Agronomy and Economy. We're doing a series with Dr. Manske. Again, I'm Ryan Buetow, an NDSU Area Extension Specialist in Cropping Systems.
And I'm Levi Helmuth, an instructor with the North Dakota Farm Business Management Program, employee of BSC. And yeah, we guess we failed to mention that last time. We kind of decided to do like a mini series, I guess, with this. I don't have our topic of the day is Dr. Lee Manske. I don't have an economic market report, but this is episode 2 of our kind of what we're going to do is a 3-part series, I believe.
Definitely. And we left off last time talking a little bit about what goes on under the soil. I guess this time we can talk a bit more in depth about that, I guess.
Soil organisms are tiny, and you have to have a good microscope to see them. So it's hard to manage things that you don't see. But these organisms are extremely important, and they weigh more than the livestock on a ranch.
Wow.
Did not know that.
And well, actually, they're going to weigh much more than that.
Yeah. I suppose it's a solid. How deep down do they usually go, I guess, into the soil?
We only go down 4 feet with our probes.
Okay. But they probably go further.
You go
They-
4
they
feet
probably-
across just like 140 acres. I mean, yeah, I can see
That's
that.
quite a bit of weight there, yeah.
And there's a misconception, primarily in crop production, in that they think that these soil organisms can eat straw.
They need something live.
They need carbohydrate. They don't have any chlorophyll,
Right.
so they can't capture sunlight themselves. And so they need energy. All of the energy that they get has to come from live plants.
Okay.
And that includes in crop ground. If you look up how to do a compost pile, you put green and brown.
Mm-hmm.
Okay, but the energy in the brown is what creates the heat of a compost pile.
Okay.
The fungi, and there's a few bacteria that have enzymes that can break the straw fibers down.
Okay.
And so they do decompose them. But all that energy escapes. If it's in a crop ground, it escapes as heat from the soil. If it's in a compost pile, it produces the heat
Right.
of the compost pile. But that energy is not available to the soil organisms.
Okay.
It's just the live plant carbohydrates. Now, all plants leak carbohydrates. Okay, but there are scientists, I think at Purdue, and it may be some of the plants, they're trying to genetically change the plants so they don't leak the carbohydrates and start producing more product.
Oh, okay.
Okay, so we're gonna get rid of all our soil organisms that we have.
Yeah, that's
They got to be fed plant carbohydrates.
right.
Now, all of the mechanisms in grasses that have developed to coexist with grazing is the tillering, water use efficiency, compensatory growth from replacing leaves that the cattle remove, and nutrient uptake from the soil. Okay, those are all mechanisms that grasses have developed, but have a minimum requirement for those to have 100 pounds of mineral nitrogen available. The problem is that all our traditional grazing management practices permit only 50 to 60 pounds. So all traditional grazing managements are not activating the essential mechanisms to make the grasses coexist with grazing.
Okay.
All right. And the only way that we can get 100 pounds is to provide plant surplus carbohydrates to be exudated from the plant into the soil where the soil organisms get.
Okay.
Now, all plants have some leakage, but if we just use the leakage, we're at about 10% of the soil organism biomass that we need to get 100 pounds of mineral nitrogen converted from organic nitrogen.
Okay.
So the grass, when it's at the vegetative stage, fixes more carbon than it needs for leaf growth.
Right.
Okay, and we can use the cattle then from 1st of June to middle of July on a 3 pasture system to remove 25% of the leaves. That kicks the plant into saying, well, I'm losing my nitrogen and I got too much carbon in the plant, so then it actually physically removes the surplus carbon
And that feeds the
and
soil.
it feeds the soil organisms. The soil organisms build up in biomass when they get this energy, and they take the organic matter in the soil and convert the organic nutrients of organic nitrogen
Right.
into mineral nitrogen. And then they produce available mineral nitrogen at quantities greater than 100 pounds. And then all of these mechanisms of water use efficiency, vegetative reproduction, compensatory growth to replace the bitten leaves, with 100 pounds, we get 140% of the weight of the leaf that the cows removed. So if the cows remove 100 pounds and we got 100 pounds of mineral nitrogen available, we get 140 pounds of leaf weight produced from that activation,
Okay.
if we have 100 pounds of mineral nitrogen.
Right.
So if we're untraditional and we only get 50 pounds, we lose that weight from the plant community, and they don't replace that.
And there's only other than using synthetic fertilizers, there's only a few ways to get nitrogen into the ground. I think lightning is a very low way, and there's also some
Lightning, the lightning separates the N2 gas,
Yep.
and it breaks up the O2, and we get nitrogen oxides that can precipitate out, and that's about 6 pounds of nitrogen per acre per year.
Right.
And we remove, in calf weight, we remove about 4 pounds.
Yeah.
Okay, now there's another way that isn't very well advertised. The volatile nitrogens that escape from the soil,
Okay.
the plants are actually able to capture that through the stomata.
Really.
Yeah, and so a lot of that escaped ammonium then is picked up back, except for on hot days when you go out in the pasture and you can actually smell the ammonium.
Yeah.
That's getting above the grass height.
Yep. Yeah.
So, but that goes back in stomata and that's recycled back into plants.
Okay.
So it's more than the 6 pounds because they're getting, and I don't know what the weight is there, but it's quite a bit of nitrogen is recycled that way.
Okay.
So all of that nitrogen that's lost from cropland that doesn't have a grass base, that's true loss.
Yep.
In grassland, they
can
pick it back
recycle
up,
some.
and so we don't, there's some that's true loss, but
Yep.
Not
it's
as much.
not as much.
Okay.
The important thing here is that normal leakage, we only get 10% of the soil organism biomass that we need. So we have to manage the grasses specifically to get that surplus carbohydrates that they have while they're vegetative. once they go reproductive, then all of that they don't have surplus stored there. And then they move that to the seeds, fill the seeds. However, that happens to be only 50% efficient.
Okay.
So if they're producing 100 pounds of carbohydrates, 50 pounds of that goes into the seeds, and the other 50 pounds is respired out.
That's the loss of what
That's the loss.
Yeah.
So we have the vegetative stage is the only time that we can get grass, carbohydrates into the soil to feed the soil organism, to build the population enough to convert organic nitrogen to mineral nitrogen, so that we can get the 100 pounds of available mineral nitrogen, and then we leave that's 67 to 75% of the leaf weight to capture the carbon that we need to do all these processes.
Definitely.
And so in the actual management, we're just turned out there and we're in the pasture 15 days, go to the next one, 15 days, and go to the next one. The science behind that is actually pretty intense and
Yeah.
pretty involved. And we've only got a 45-day window every year that we can stimulate and get the carbon down into the ground to build a soil organism population, build up enough to keep us at 100 pounds of mineral nitrogen. And it's pretty, and it only happens those 45 days because grass plants are set on the length of daylight. We have a 45-day window every year, exactly at the same time every year. And if we miss that, we lose the whole set of increased production.
So if someone decided to go from a cropland to try to put a rangeland out there or some pasture, I guess if they had a crop for a year or something like that, how long can those soil bacteria survive without having a living plant? Is it not very long?
There's two sets of soil organisms.
Okay.
The rhizosphere organisms that live in association with a perennial root.
Okay.
Okay, they're completely gone in 14 months after you take the perennial plants out of the ecosystem.
makes sense.
Okay, then there's a small amount of edaphosphere. Edapho is soil sphere. They're the single organism. Now they've got bacteria, protozoas, fungi that are edaphosphere, and fungi, bacteria, protozoas that are rhizosphere. They don't switch back and forth. We call them birds,
Yeah.
fungi, the bird, but we don't go from an eagle to a grouse.
Right. Right.
And so those fungi that are edaphosphere are always edaphosphere.
Okay.
Those fungi that are rhizosphere have to have a perennial root
Yeah.
or they're dead.
Yep.
Yeah.
Okay. There's only one graduate student in all of the world that has quantitatively separated rhizosphere organisms from edaphosphere. That's in Great Britain. And he did a hypothetical cubic meter of grassland soil. And it's about 1 billion times fewer edaphospheres than rhizospheres in a grassland.
Wow.
So if you got 1,000,000,001 over here, you get one in the edaphosphere. So if we remove perennial roots, we start with crop ground at the 1,
Yeah.
or 1/1,000,000,000th of the biomass that we had when we had a grassland.
Certainly something you'd want to think about with some of the CRP that's coming out of going into crop ground. Would that definitely have some ramification for you guys that way?
All of the papagules for rhizosphere soil organisms do not spread in the air.
Okay.
They get to on the exoskeleton of little insects or mites
Right.
that are moving 6 or 8 inches a year.
So it takes a long time for this bacteria to get established, and even if the CRP has been there for 5 years, you might not quite have the
Yeah.
bacteria you'd have in a native.
Right. The best that I think we've got some old crop ground in the Badlands that was 10, 15 acres that was plowed up in Homestead period that weren't seeded back.
Okay.
Okay, a lot of those are coming up, could be 100 years that they haven't been plowed.
Okay.
They're not back to native, they got native species there, but they're not a full ecosystem,
They're not back to where
the
the
pre-plowed.
yeah.
Right.
And
Past
so,
that 14 months, it,
right, now, surprisingly, crested wheatgrass can develop a rhizosphere. And if it's on the edge of a native prairie, in about 30 to 35 years, we can get most of those crested plants back symbiotically with rhizosphere organisms.
okay.
And smooth brome has been domesticated for well over 500 years, and I've been saying that for 40 years. So pretty soon we're going to have to go to 600 years.
Yeah.
But smooth brome has been domesticated a long time. It absolutely will not form an association with soil organisms.
Okay.
It absolutely rejects that.
So some of these more times these moving over to crops, I guess. I mean, an older crop, I guess you think of flax, and that can use phosphorus a bit better through using fungi. And some of these crops that have been bred more, I guess, domesticated more, do you think they're kind of lacking those relationships a bit?
Well, if we got agronomists that are developing plants that don't leak,
I don't think. Yeah.
we're going to get away from all soil organisms. The eudaphosphere has a group that form associations with plants, and then there's a small group that absolutely have no association with plants.
Okay.
They don't move very far. So wherever the seed comes, if there's a small area, then and that starts leaking, then this biomass of eudaphosphere will grow and form a symbiotic relationship with the cropland plant.
Okay.
But they're as individuals, not as a team.
System. Right.
Yeah, if they got bacteria and if they got fungi, they're not working together on the cropland plants.
Right.
And they're at a biomass that's
Much-
magnitudes less than what we got.
So you're getting much more productivity out of the microbes in the prairie soils.
Yeah.
Okay.
Now, one of the things that also is associated here is the domestication of native grass seeds.
Okay.
Okay. If we go and wild harvest native grass seeds, which are obligate for soil organisms, and we take that seed and put it into something that's been cropped for 100 years, there's only a eudaphosphere, no rhizosphere organism there. That first crop is usually very thin, because the seeds that are obligate die.
Right.
And they're the seeds that are facultative, that can live with or without.
Yep.
There's a low percentage of the seeds,
Right.
but they're the only ones that grow.
Because they need that.
So you're selectively, as you domesticate, you're selecting for those ones that have less and less of a relationship with the soil, with those soil microbes.
The only ones that we get successfully grow are those that can live without.
Yeah.
Yeah.
They have no association.
Okay.
Zero. They go from 100% to zero in the first seeding.
Sure.
They're
Okay.
not quite as.
So then that harvest, and you increase that again, then you have to do that several times to get a good quantity of seed. Almost all of those seeds then are going to be genetically set for being facultative.
Right.
Okay, now, so all the reseeded native grasslands, in CRP or wherever. We don't know how long that's going to take for those plants to convert over and become a true
Just because
ecosystem.
it's a native plant doesn't mean it's going to have that same relationship that the same native plants. That the genes are different enough, or they're
Yeah, they have several sets of chromosomes. That's why we can have a little blue stem on top of the hill and a little blue stem at the bottom of the hill.
yeah.
They're using different set of chromosomes.
Yep.
Okay.
They look the same.
Yeah.
You put them together, they
Yep.
look the same plant, but they've got sets of, 60 sets of chromosomes or more,
Yep.
and they're using only one set at a time,
Yeah.
and they can do that.
And you get into different ecotypes sometimes too, but
That's ecotypes. So, so the only ecotype that we get when we take the wild seed and put it in crop ground is those that are facultative.
yep.
We lose all the obligates. And I don't think anybody's studying how long it takes to get those facultative back to a true ecosystem.
But that have quite the impact, far as whether we're talking CRP and taking rangeland, taking crop ground and trying to put it back into rangeland, or if you're talking, I'm thinking with the oil field and with going back in and doing some reclaimed ground on that, or mining, or any of
Right,
those
if we're seeding native seed, it's not native ecosystem
yeah,
until we have the soil organisms cycling the nutrients.
we need to make
That's what an ecosystem is.
yeah. You need to make sure, like we said, the just the native plant species doesn't mean the native ecosystem. I guess that's the
Exactly.
way you need to put the way to
And
phrase that.
this, now, even like crested, having a introduced
Yeah.
species, and if in 30, 35 years it develops a symbiotic relationship, it becomes a true ecosystem, even though it's an introduced species.
Right. Sometimes the only thing that's constant is change, right? So
Yeah.
it's what truly is a native.
These soil organisms are so important, and we actually spend very little time on managing them, and they make everything work,
Yeah.
and they're so important.
That's some incredible stuff. I think that's all we have for this video. Thanks for joining us.
Thanks for stopping by.